Welcome and thank you for joining. We are reviewing prerequisite skills from grade 9, and this time we're looking at how to graph the equation of a line. Now remember that the equation of a line can be given in slope y-intercept form. Like in this example, we have y equals negative 3x minus 4. It is very easy to draw the graph of the equation of a line from the slope y-intercept form by simply using the slope and the y-intercept. So let's start off by identifying the slope. So the slope is the number before x, just the number, okay? So the numerical value or the numerical coefficient of the term, not the x. And the y-intercept is this number that is sitting here by itself, so negative 4. Just like the name says it, the slope will tell us how big the slope is, so how steep the slope is, and the y-intercept will tell us where the graph intersects the y-axis. It is very easy to start graphing the equation of a line from the y-intercept. So since the y-intercept is equal to negative 4, it means that the line will pass through y equals negative 4 on the y-axis. So we'll start off by marking the y-intercept, and next we have to apply the slope. It is easiest to apply the slope when it's given in fraction form, and as you can see, this is not in fraction form. So what we do is we turn it into a fraction, and now we can see that the rise is negative 3 and the run is positive 1. So from the y-intercept, we apply the slope. So what that means is from the y-intercept here, we're going to rise negative 3, which means that we have to go down 3 units, and to run 1, which means we have to go to the right 1 unit. We stop there and we mark the point. So to draw the graph of a line, to draw any line, all we need is 2 points. And, oopsie, we'll connect them. Now, you're probably wondering, wait a second, I remember in grade 9, we talked about switching the sign from numerator to denominator because, when you write negative 3 over 1 or 3 over negative 1, that means the same thing. So if we write the slope, the same slope of negative 3 as 3 over negative 1, it means that the rise will be positive 3 and the run negative 1. So what happens then? Do we still get the same line? Are we allowed to switch the sign from numerator to denominator? Well, let's see. If the rise is 3, it means that from the y-intercept we have to go up 3 units. And if the run is negative 1, it means that from where we're at, we have to go to the left 1. So this is where exactly we land on. So right here. Now you connect this point with the y-intercept. As you can see, we obtain the exact same line. So it doesn't really matter how we apply the slope when we have a negative involved in it. So as negative 3 over 1 or 3 over negative 1, it still gives us the same graph of a line. You can try the next one on your own. This time we have slope equal to 3 over 4 and y-intercept equals 3. So we're going to start off with the y-intercept. Y-intercept is 3, which means the line will pass at y equals 3 on the y-axis. Now we apply the slope from here, which means that we will be rising 3 units and running 4. So rise positive 3 means that we're going up 3, and running positive 4 means we can go to the right 4, and that's where we stop. And we connect the y-intercept with a new point we created, and voila, this would be the graph of the line. You extend the line at both ends, and it is important to label the lines by their equations. So 3 over 4x plus 3. Now again, just like we did before, number 3 over 4 can also be written in the form negative 3 over negative 4. It still had the same value, right? So that would mean that the rise will be negative 3 and the run negative 4, which means that from the y-intercept, always the same y-intercept, we can rise negative 3, so that means we go down negative 3, and you can run negative 4, which means you can go left 4 units and stop here. Connect this point with the y-intercept, and as you can see, we have created, or we have drawn the exact same line, so it's just an extension. So it doesn't matter how we treat the slope, right? So where we put the positives and the negatives, we still get the same graph. So next we're looking at horizontal and vertical lines. So first, from the point with coordinates 0, 3, we have to draw a horizontal line. So x equals 0, y equals 3 will be right on the y-axis. And from the y-axis, right here, I will be drawing a horizontal line. There it is. And arrows at both ends. And we're going to have to determine the stop. So to find the stop of a line, we pick any 2 points and we figure out how far we have to rise, how far we have to run to go from one point to the other. So I'm going to pick this point here, point A, and this point here, point B. And we're going to say that to go from point A to point B, I don't really have to rise. So in this case, we say that we rise 0. And for running, then it seems that we have to run 5 units in this case to the right. So 0 over 5 would be equal to 0, which means that the slope will be equal to 0. And that's the reason why we say that horizontal lines have a steepness of 0 or a slope of 0. The y-intercept is exactly equal to 3. The same as the point that we're given. Now, if you want to write the equation in slope y-intercept form, y equals mx plus b, it means that we're writing it as y equals, the slope is 0 times x plus 3. 0 times any number would give 0, so that means the equation of this line will be y equals 3. And the equations of all horizontal lines are in the form y equals a number. And that number will be the y-coordinate of any point on the line, because it remains the same throughout the line. Next, we are looking at vertical lines. So from the point P with coordinates 4 and 0, so here is the point P with coordinates 4 and 0, right on the x-axis. We are drawing a vertical line. Arrows. And we have to determine the slope. So to find the slope, I'm going to pick 2 points here. So I'm going to call this the point P, and this one here the point Q. So in order to determine the slope, I have to figure out how to get from P to Q by simply rising and running on the coordinate grid. So in order to go from P to Q, or from Q to P, doesn't really matter, but I'm choosing P as my starting point here. So I have to rise 1, 2, 3, 4, 5 down, which means that the rise would be equal to -5. So once you rise, you are at point Q, which means you don't need to run, which makes the run equal to 0. -5 divided by 0 is undefined, and the calculator will give an error. And this is what happens when the line is vertical. So a vertical line is the steepest line there can be, and we say that the line is so steep we cannot even measure the steepness. That's one way of putting it. Now, the y-intercept in this case is non-existent because the line is parallel to the y-axis. So, none. And the only information we know about this line is that at any point on this line, the x-coordinate will be equal to 4. So the equation of a vertical line then is in the form x equals 4, which is the x-coordinate at the given point. Now, if we were to determine the point of intersection between these two lines, that's a point of intersection, would say that the x-coordinate is 4 and the y-coordinate is 3. So if you're ever given a question on the test that says, graph this horizontal line and graph that vertical line, find the point of intersection, all you have to do is grab the x from the vertical line the y from the horizontal line, and that would be your point of intersection. Four and 3. Now we're going to take a look at some examples. So what is the equation of a horizontal line that passes through 0, 5? So whenever I see the word horizontal, I know that the equation will be y equals a number. Whenever I see the word vertical, it means that the equation will be x equals a number. So follow the examples we just did. Now, if the line is horizontal and it passes through the point with coordinates 0 and 5, it means that y equals 5. And that would be the equation of the horizontal line. It's a quicker way of getting the equation. If the line is vertical and passes through 5 and 0, it means that x equals 5 will be the equation. In the next example,